equal to ax square plus bx plus c, where a is the coefficient of x square, b is the coefficient of x, and c is constant term. So we find out discriminant, and that is equal to delta, notation is delta, b square minus 4ac. So we find this value, and based on this value we will determine that what will be the roots of the given quadratic equation. So first case is if the discriminant delta is greater than 0. So if the value of the discriminant is greater than 0, in this case we have two distinct real roots. And if I talk about the graph of the quadratic function, so that will be somewhat, this is our x-axis like this. If a is greater than 0, it's concave up and it will be cutting x-axis at 2 points. Another case, if a is less than 0, then our graph will be concave downward, and again it will be cutting at 2 points because it has two distinct real roots. Next case can be if we have the discriminant value equal to 0. So in this case we have one repeated real root, and the graph of the function will be somewhat like this. It will touch the x-axis at 1 point if a is greater than 0, and if a is less than 0, then it will be somewhat like this. Here it will touch a less than 0, because in that case the shape will be concave down. And third case can be when we have discriminant less than 0. So when discriminant is less than 0, in that case we have no real roots, and the graph will look somewhat like this. It will neither touch or cut the x-axis, and if it is concave down, so it will be somewhat like this. So these are the three possibilities, three cases that we can have in case of a quadratic equation. Either we have two distinct real roots, either we have one real repeated root, or no real root. So you just need to find the discriminant delta, that is b square minus 4ac, and you can just determine the nature of the roots of a given quadratic equation. So that's all for this video. I hope that the concept of discriminant is clear to you. Do like, share, comment and subscribe to my channel, and stay tuned for more such videos. Thank you so much for watching.